CE 8502 Structural Analysis 1 Degree of Static and Kinematic Indeterminate Structures prepared by Anand A. AP Civil, Rohini College of Engineering and Technology. Degree of Static and Kinematic Indeterminacy of Structures. A structural system that can be analyzed by using the equations of static equilibrium only is called statically determinate structure. That is, reaction components and internal stresses can be calculated using static equilibrium equations only. Example, simply supported beam, if it cannot be analyzed by the equations of static equilibrium alone, then it is called a statically indeterminate structure. Example, fixed beam. A structural system is said to be kinematically indeterminate if the displacement components of its joints cannot be determined by the compactability equations alone. Example, simply supported beam. If those unknown quantities can be found by using compactability equations alone, then the structure is called kinematically determinate structures. Example, fixed beam. But before calculating a degree of indeterminacy of a structure, it is good to know about its stability. If a structure is unstable, then it does not matter whether it is statically determinate or indeterminate. In all cases, such types of structures should be avoided in practice. And next, stability of a structure. The stability of a structure is of the following types. First one is external stability and second one is internal stability. First we can see the external stability. For a structure to be externally stable, the reactive forces should be non-parallel and non-concurrent. So this is the diagram, externally unstable system. And next, internal stability. An internally unstable system can change its shape without any deformation of its members. So this is the internally unstable systems, plane frames and trusses. And next, indeterminacy of a structures. The degree of static indeterminacy or degree of redundancy show the number of additional equations required to solve the system. External indeterminacy is related to the support system of the structure, whereas internal determinacy is related to the internal stress in the members of the structure. The degree of kinematic indeterminacy shows the number of unknown joints deformations. So this is the flow chart. Indeterminacy, that is static and kinematic. For static, there is a external and internal. And next, so degree of static indeterminacy of pin jointed plane frames, that is plane trusses. The simplest form of a stable plane truss is a triangle having 3 members and 3 joints. Then for each additional joint, 2 extra members are required. In this way, a stable and internally determinate truss system can be formed. Thus, considering all the joints except the first 3 joints that form the basic triangle, that is 2 into j minus 3, numbers of members will be required. And then adding the first 3 members that form the basic triangle, the total number of members in a truss can be formulated as below. Small m is equal to 2 into small j minus 3 plus 3, or m is equal to 2 into j minus 6 plus 3, where small j is joints. So where small m is number of members and j is number of joints. Hence, if a plane truss is formed with 2j minus 3 members since m is equal to j minus 3, and if they are arranged in a suitable manner that the system cannot change in its shapes without deformation of its members, then a stable and internally determinate plane truss is formed. Thus, the degree of internal indeterminacy for a plane truss is m minus 2j minus 3. The equation of static equilibrium available in order to find reaction forces in the plane trusses is 3. That is, h is equal to 0, v is equal to 0, m is equal to 0. That is horizontal, vertical and moment. If small r be the number of unknowns reaction forces, then the degree of external indeterminacy related to the support system is small r is r minus 3. Thus, the degree of external indeterminacy for a plane truss is small r minus 3. Finally, the total degree of static indeterminacy is the summation of the degree of internal indeterminacy and the degree of external indeterminacy. Thank you.